Well, you guys are good, so I'm not shocked, but you came up with that rather quickly. So congratulations, that was almost instant. Okay, so this equals 2 square root of x because, of course, there's no dependence on the delta y here. And the square root of x, delta y, goes to 0 of. You multiply this by this square root plus this square root. Okay? So I'm just going to say multiply both sides, numerator and denominator. And I didn't say numerator and denominator. You know what we're doing here because you know your algebra pretty well. So we have y plus delta y minus y over the square root of y plus delta y plus square root of y times delta y. Okay? Well, that simplifies very easily. Y minus y is 0, and delta y over delta y is 1, right? And then, as delta y goes to 0, this just becomes square root of y plus square root of y. That's 2 square root of y, right? So this equals 2 square root of x times 1 over 2 square root of y. Okay? Which, of course, then equals square root of x over y, but this kind of obscures the relationships, okay? Make sense? Again, we see that when we factor out the 2 square root of x, we're left with this expression that is the derivative of y with respect to t. Sorry, the derivative of the square root of y with respect to y, okay? When we take the limit. And then we did that just like we did in first year calculus, okay? And we get this. Okay, that's pretty good. And then I'll just comment that fx of xy, I mean, we have a symmetry between the x and the y, right? So we just reverse the, x and y coordinates, and we get the square root of y over x, right? And you can work that out. But the rule is actually fairly simple. This is the same thing you get, and I don't really have room to write it out. I don't want to do it just by waving my hands, but for the moment I will. If you treat x as a constant and take the derivative with respect to y, right? If you treat x as a constant, you get a 2 square root of x times the square root of y, and you take the derivative of that with respect to y, you get 1 over 2 square root of y, and so forth, okay? So you very easily this expression is the same thing you get if you took the derivative of 2 square root of xy with respect to y, treating x as a constant, okay? And this is, well, analogous. Okay, so that's how you calculate them. This is why you calculate them that way. And if you think about how x and y move through this expression, you understand why, because 2 square root of x is constant with respect to delta y, right? So it just factors out, and now you have the derivative of this thing, okay?